The great thing about Interset is it leverages 100% unsupervised online or self-aware machine learning. And that's in stark contrast to competitive products out there on the marketplace that require supervised approach. And Will's going to go into the differences between those two, but just know that a lot of our customers tell us they find faster time to value with less human interaction by using the unsupervised machine learning approach. We support 13 different types of data. So everything from access to VPN with endpoints and printers and proxies and things in the middle. We have almost 500 unsupervised machine learning models, as we call them. And another huge differentiator for Interset and why us, our CTO, several of our key dev folks came out of what is now known as, what was Cognos, which got acquired by IBM, and now they call it Watson. So this team, this isn't their first rodeo when it comes to analytics. So over the last 5 years, a lot of security companies have touted analytics or ML or AI and had to work their way there. In contrast to that, we're actually an analytics company with a lot of analytics lineage, applying that proven knowledge to a cybersecurity problem. I've been doing this for about 7 years, and another testimony for the Interset space is the In-Q-Tel investment. Much like ArcSight was an In-Q-Tel portfolio company back in the day, so was Interset, and that's the venture capital investment arm for the U.S. Intel community. So a little bit of who we are and where we came from. So what do we do? So we're leveraging the existing security data logs that you have in place today, and we're providing a fresh insight, a different lens, if you will. And we're not here to say dump your SIM or get rid of this or get rid of that. There's certainly going to be a place for signature matching and writing rules, but you cannot write a rule for an unknown. And we're all about surfacing the unknown. So we do that through the mathematical equations that I mentioned before, and we're able to create a unique normal for everything in the enterprise that we're watching. And when something deviates, we can tell you how weird it is. Folks often ask, just in a nutshell, what does Interset or ArcSight Intelligence do? Frankly, we distill billions of events into a handful of prioritized threat leads with some context around it. Why do you care? Why did it become weird? That's what we're all about. And so how do we do it? I mentioned before, we're going to mine not just endpoint data, but all data sources that we're looking for. Endpoint's a really rich source for us. And we're going to create this unique normal for every entity, user, machine, IP address in the enterprise. And when something deviates from that norm, we tell you why. And if you take a look here at the green being a good bell curve and the red being a bad bell curve, and arbitrarily just kind of drawing a line in the sand there as creating a threshold at, say, 50 megabytes in this example. Wherever you draw that line in the sand, you're going to either get flooded with false positives, or you're going to miss some low and slow. And with our approach, we're actually putting it in context of why this entity became weird for us. And we do that in a really simple approach. We simply need the metadata from the logs that are already in place. And this kind of illustrates what we're looking for from our log sources. That we're looking for, a user or machine doing something to some asset and how they're doing that. We can take a look at the further illustration of this in the next slide that kind of calls out those exact log sources that we're talking about, or those fields in that log source. But one thing I want to point out here is, yes, all of these models work off the shelf, but of course, everybody's got specific use cases in their environment. So if you look at the equation in the upper right there, where the W's are depicted, those are the weights, right? So these are pre-configured from the factory, but you may have a use case where a user, for example, is a contractor, or perhaps somebody that's on a PIP list and about to be walked out the door next week. You might want to increase the weight on them, or maybe the asset is a honeypot and you want to increase the weight on that. And the tool allows all that flexibility so that you can adjust weights of models in mass or by individual. So let's take a look at how we quantify this risk. We bind all of our risk ratings in a 0 to 100 fashion. You'll see that in the demo in just a few minutes in the UI. We think humans think that way. And so we're telling a story. In this case, we see a user that works at a weird working hour, that VPNs from China, accesses repositories that she and her peers don't normally do. We use peer clustering. You don't have to tell us who the peers are. We model like for like behavior. And now she's taking things an unusual number of time and moving a lot of data. And so that's elevated the risk of this user from, say, a 2 or a 3 all the way up to a 96. And again, I know if something's 96% risky, I should probably go take a look at it. So let's take a look at how we derived that story. We did that from 3 log sources. So unlike a SIM or a log correlation tool, where you're trying to collect a ton of information from every source that spits out a log, we're really focused on what data sources feed our models. What do we care about? What use cases are we trying to solve? And we did that last illustration from 3 different ones. Repository or repo logs. That's a source code repository. It could be a SharePoint file or some kind of data store. Active Directory or access logs, and VPN logs. And we could work on one of those data sources, but they become more authoritative with multiple sources. The nice thing about our platform is it does a secondary parental squash out on the back end here to really compare and contrast what the other models saw. And at that point, we could also introduce other expert systems like DLP or a threat feed or a vulnerability posture to maybe raise that risk score from a 96 to a 98 if we knew that this user had sent out credit cards, for example. All right, so let's take a look. I mentioned a little bit about source code, and that's something that's kind of close to our heart. Is some of our first models were around source code repositories, and if you look at kind of what's going on that we're all reacting to here, recent of late with the SolarWinds incident, that's a prime illustration of if we were watching the source code library there and saw nefarious things happen, news ports and services spinning up that hadn't been done before, our anomaly detection could have certainly surfaced a lot of weird behavior around that. It's unfortunate that we were watching their source code library. But source code is really something that we've done a lot of over the last 5 to 7 years. And one of those was actually a security vendor was using us to basically see if we were able to detect something they had an issue with. And the nice thing about it is we did this from just Active Directory. We were able to surface some guest accounts that were being used in lateral movement. And we did this within 24 hours of given the logs, right? So this was an extremely nimble activity for us. And it's because the outliers are really surfaced. And folks will often ask, what if bad behavior is being modeled or profiled as we create our baseline? We're really good at catching that as well. The low and slow is what we're about because it stands out from others. Another one was a high-tech firm that actually had an incident. They had 2 engineers that stole some data. They spent $1 million with a very large security vendor. They came back and said, you need something like Interset. They brought us in and they gave us the source code logs for 2 months around that incident. And we quickly, within a few hours, said, oh, were these the 2 guys that you fired? And they said, yeah. And they said, well, did you know about these other 3 people that are here in this location and 8 others that are in China that were doing the same thing? And they were all in collusion. And their faces hit the floor and they said no. And so, it's pretty telling that they spent a year with a security vendor that did a full forensics analysis assessment. We took 2 months worth of source code logs and we were able to surface the source code developer engineers that were stealing from them. And again, that's just kind of the power of the math. And a lot of that's from, the unusual times of day, check in, check out, the way that they're interacting with the data. We've got several models around source code that allow us to surface that kind of trusted insider. They're supposed to interact with the source code, but because of the way they started doing it, it became very clear that they were doing it for ill-forgotten gain. And as I mentioned before, we're just looking at, really just a few column headers from the source code library, right? So the timestamp, who was it, and these can all be hashed, doesn't matter to the math. What were they doing and to what resource, right? It was a project or file or so forth and so on. And so we're able to derive all that from simply gleaning the source code library metadata. We actually have 35 different source code anomaly models, and we kind of put them into a couple of different buckets here, which are kind of humorous to us. And we've got sneaking, right? There are folks that are kind of, looking around to see what they can do. And then hoarding is a really interesting one because typically developers work in sort of a one-to-one interaction. They take the source code down, they make changes to it, they put it back. It's very much a give and take kind of thing. Wandering models also are indicative of somebody poking around where they have access to it, but they've never used it before. And mooching is my favorite one. That's kind of like the fat kid when we were all in middle school that came over and ate all your snacks and never brought any snacks to your pantry. And so when we see mooching, that's very indicative of someone that's probably about to leave as well.
Another interesting group that gets categorized as mooching is your security ops folks. They don't contribute any code, but they pull it. So one of the questions, right, we often get is about false positives. If you know that you're a constant puller or a mooch because you're in security ops, the system will develop a baseline for you.
Yeah, indeed. Thanks, Will. Absolutely. And again, it's not simply just around unusual time, but we can have a pretty definitive view of someone's real working hours. So if, for example, maybe their account was compromised and something bad's happening at night, that's an easy indicator that something has gone awry. We're not married to any one specific methodology, by the way. If it's Gaussian, great. If it's Bayesian, great. Whatever the best model is for the data source and the use cases that we're there for. These are common. We actually did this with real customer data. These are common kind of indicators where we see an engineer that regularly works 6 days a week. You can see that they take lunch. You can see kind of exactly when they come in. And then engineer 2, 5 days a week, very active during sprint on Thursdays, never worked the weekend. When we actually asked the customer who gave us this data, we said, was engineer number 2 by chance a contractor? In fact, they were. So the math doesn't lie. This is another unique source code project that we did where a customer gave us their logs around their source code library for, I believe it was a month or 2 as well. And they were blown away when we came back in and said, you have 4 distinct source code projects. And nobody told us that. The math surfaced that they've got this tiny little maintenance project over here in the purple on the upper right, and they only have 2 people that kind of maintain that. They've got another smaller one that's spinning up with just a few folks on the teal one on the bottom left. And then their core products or projects are the red and the green. But what we noticed was an outlier from Team Red that was interfacing with Team Green in that project, and that became very abnormal for the way that they were interacting and doing things from red to green that people in green weren't doing. And so that's how we were able to really surface that that was in fact an insider threat. Yep, that guy right there. So I'm going to pass it off to Will, and Will's going to cover more about the unsupervised versus the supervised machine learning approach.
Hey, good afternoon, everybody. So I'm going to try and pop through the slides so I can actually get into the demo portion because, hey, that whole picture is worth 1,000 words. Actual product demo is probably worth about 10K then. What I got here is just kind of a quick screen grab on the bottom of one of our users, Sheila Mathis, and the romper room graphics that kind of highlight how easy it is to really detect when something is unusual. And you can see that observed line, right, which is dark compared to the average and the larger. As I run through my demo, I'll actually show you some instances where service accounts and others could skew a traditional system, but don't fool us because we look at the individual and we look at their peers. So just kind of, bam, quick piece. Now, what's the difference between supervised and unsupervised learning? Get that question quite a bit. Supervised learning is actually teaching the system how to identify something. And in this case, right, we look at the eyebrows, the curve of the mouth, and everything else. And so the system, given hundreds of pictures, can then start to sort out emotions based upon how features within the face are used. Some security agencies are using these in airports to look for nervous behavior, people who are extremely anxious, et cetera, right? Finding somebody who's terrified of flying versus somebody who's got a bomb in their shoe could be a little bit challenging, but that's the idea. Supervised learning is training the system how to identify something. And as you can imagine, we're not talking about 4 or 5 samples here. We're talking about tens of thousands of samples. And so a lot of people will say supervised machine learning is bad and you need unsupervised machine learning. And our data scientists and others would come back and tell you that's not absolutely the case, right? There is a place for supervised learning, malware detection, virus detection, things that behave in a certain manner that can be identified by ports, that can be identified by executables, things like that. Signature-based detection is really what supervised learning is. So if somebody tells you they've got unsupervised learning, but they're asking you to update your signatures quarterly, I'm going to throw the flag and say there's a penalty on the play here. Nope. Unsupervised doesn't need any interaction from you and I, the end user. So here's kind of an example. I like to use it just because it's mildly humorous. We're going to take a look at this individual, right? We don't know him. His friends may know him. We take a look at these pictures and how does unsupervised machine learning learn about an individual? So the first thing that the system would do is group characteristics. So the left-hand side looks like individuals maybe playing peekaboo with a baby. Same thing with that pot that he's got holding over a pan over his head, right? That kind of activity, is that normal? I see multiple cases here of that individual exhibiting that behavior and probably going to say that's okay. And then I've got the individual cleaning. This person a neat freak, that may be okay. Maybe they were the world's biggest slob, in which case cleaning up, right, could be unusual. And then the other one here is they're drinking what looks like a cup of coffee they bought, and then the other one is they're pouring it at the house. And so which one of those is unusual, right? If we know the person, we can pick that out easily. But if we don't know the person, we can't. And here's where the system learns the behaviors and helps us out, right? So in this particular case, drinking coffee from a coffee shop is the unusual behavior for this user. So, right, not deliberately security related. We don't care that they're buying a cup of coffee. The idea here is for you to see how the system groups behaviors and then applies that behavior grouping to what's normal and what's not. And as I go through the demo, I'll show you some real world examples using security. One of the questions that I often get from customers is, what do I need to feed the system? Right? Because many of us as security pros are familiar with SIEMs and traditional logging solutions where it's kind of a, back up the truck and unload everything into the bin. And then I like to call it spray and pray that you're going to find something. An insider threat tool like Interset's ArcSight Intelligence is very, very specific about what we feed it. You saw the example that Jason covered earlier about those 3 sources providing a wealth of information. One of the things that we really like is the endpoints, right? The EDR data. In particular, we've got a really great relationship with CrowdStrike. So if you're a CrowdStrike customer and you're worried about insider threat, reach up to the CrowdStrike store, click try it now, and in a week or 2, Jason and I'll reach out to you after we get the ping and we can continue the dialogue. It's pretty slick. So if you're looking to get a real world example with your data, there isn't anything easier than going up to the CrowdStrike store and giving that a try. And with that, we're going to end Death by PowerPoint. Yay! And pop over here, actually into my system. I hope I got the password right. Sweet. course, I want to save the password. Never. Okay, so I'm going to break the demo up into two different kind of sessions, two different flavors here. The first one, I'm going to walk you through the tool. I'm going to walk you through the interfaces, what it's got from an API perspective, what the different screens do, and kind of show you some sliders and some other pieces. The reason for that is I want to set it up so that I can do a life in the day on a demo, right? I pop in the morning, I take a look at a risky user, and I'm actually going to show you how I would do an investigation of a real entity. So the first thing I'm going to do is pause here and say right there in front of you is my overview, kind of my overall risk page, if you will. Billions of events, right? Almost 2 billion events rolled down to 500,000 anomalies and violations. And those of you that use other security tools, right, are used to alerts, you're used to triggers, different things. Anomalies are mathematical based. Those are things we've derived by looking at your baseline. And then violations, those are things that popped on a rule from an external system and popped over and fed me. One classic example is DLP. And as I go through my investigation, you'll see where the DLP actually triggered my my system, threw it over and said, hey, whoops, you better take a look. This person's moving credit card data, right? And then we just kind of roll it down to a handful of entities and then prioritize those based on a rank. If you've used other tools, you've kind of seen something like 11,389. I have no idea what that means. And at 3 o'clock in the morning, when I haven't had a cup of coffee in the last 2-3 hours, I've got even less clue. 0 to 100 just makes a ton of sense. So that's another differentiator. When Jason talked about that secondary Pareto squash, really what that means, 0 to 100, bam, life is good. So I'm currently sitting on my CrowdStrike demo data. I'm going to switch over and I'm going to show you another set of data. So this one's same, right? 2 billion events, risky entities. What I did though is I switched my source feed so that I've got more sources. If you see the dark indicators, I went from the first 4 all the way over here to websites. Yes, I can collect information from printers. A lot of people don't think about printers as an insider threat tool, but they can be. And so just kind of pause for a second and kind of roll back to some of my time as a security person in the federal government. The reason why folks like us, you guys on the phone and myself and others have a job is not that we can't secure systems, right? You can secure a system to the point where nobody can use it. The real trick is securing a system so that it's still usable by end users. And that's where compromise comes in, is allowing people to do activities, right, that they're authorized to do opens these holes that we can see. And one of those is print 6 reams of paper and walk it out the front door. Enough said on that. The other piece here is I've got an overall risk, right? I can hover over that. The computer generates some text. I can plagiarize it, put it in my monthly report, weekly report, push it off to the boss, right? It's 3 o'clock in the morning. I don't want to type a ton. I copy and paste, bam, and then I edit it for content. This middle piece shows me my risk. You can see the command and control is here. If I hover over it, it'll highlight it. So what I'm going to do is click it, take myself to another screen. This is the Explore screen. Here's a couple of not so thrilling, right, kind of pieces in the UI. I've got a slider. Everybody's got a slider, right? I use my slider to hide things that I don't want to look at, right? Low indicators, I can zoom in, right? So my timeline expands, not super sexy, but useful, and you'll see in a minute that I can do something entertaining with them. And then I've got anomalies and violations down here. And if I had an entity tagged, it would show up over here. And my tagging is a way of filtering individual entities. What are entities, you may ask? Entities are anything in the system that I monitor. That printer, an account, a service account, Bob from accounting, my VP's administrator, whoever, right? That's an entity. And I can apply tags to them if they're interesting, or I can filter on those individuals. So no craziness as I talk later here about the individual pieces. One more, as I'm going to pull up the API window. One of the questions we often get is, how well is your API documented? And, oh, that's hilarious. Give me just a second, I apologize. Sometimes the system does not behave like you want it to. And for those of you in the audience, yes, I just switched systems. It's a brand new system we just put together, and never demo a system you haven't fully tested. Shame on me. All right, so here's the Swagger API, right? And I'm dabbling in web development. I certainly don't call myself a coder, but occasionally I'll mess around with the system. So one of the things I might want to do is take a look at sessions that are open on my system. So I click in here under info, and I get session info. Now there's a bunch of information here. Status codes, implementation notes, code examples. One of the first things when I popped it open and took a look with the developer looking over my shoulders, what the heck is a status code? They laughed and said, you see them all the time. You just don't know you do. And I thought, and then they said 504. And I'm like, oh, page temporarily not found, right? And then 404, page not found, bam. And so that's what a status 200 is it's a status code. I can also click try it now. I get snippets of code that I can use in curl, right, the command line web browser. I also get a request URL. The nice thing about the system is that request is actually based on my system itself. It fills that out dynamically. Man, I love things that computers that help me out, perfect. Computers that make me think too hard, not a fan. Here's my response body, right? This is what I would get back if I was developing. And then down below that, I'll get my response header and my response code. So if I wanted to take that session stuff and put it in my own web page, I basically just got everything I need right here to pull that data and put a widget or something else into my system. And so not super sexy, but there it is, right? Good times. I am going to close those guys out so they don't confuse you, me, or the rest of the planet. All right, so with that, I'm going to take myself back to the overall risk. That's kind of a quick push. I've got entities. I've got this risk score over here we talked about. It's also color-coded, right, depending upon severity. So, right, romper room graphics at 3 o'clock in the morning, a 99 out of 100. I need to look at that before the boss shows up. Do an explore. This is where I can come in, take a look at tags. I can apply those as a filtering piece, and then events. And events will make more sense as I go through and actually do the demo. I promise you, I will show those to you as I go. So that's it. That's my interface. Now I'm going to switch roles. All right, so right, it's 8 o'clock, just rolled in, got a cup of coffee. Boss doesn't show till 8:30. I got a couple of real risky users here. I'm going to go in and take a quick look. A tag, this Joshua guy, I look over here and I'm like, uh-oh, 98. Yep, that's bad. All right, so you guys saw before, I'm going to get rid of the trash, right? Zoom in. Boom. Okay. First thing I'm going to do is I don't know Josh, right? If it was a small company of a dozen of us, maybe I know him, I know when he works, what he does, et cetera, but I don't know Josh. I'm going to click on him. Take a look here. If he was a member of Red Team or something, and I saw security spikes, I wouldn't panic. This is a well-behaved corporate citizen from a security standpoint who jumped to 98. I've got a real problem here, right? That's my first kind of sanity check, is if they've had other spikes in the past that turned out to be nothing, okay, this person's had no spikes. I got a real problem. Here's these tags we talked about, right? Some of my fellow coworkers, somebody tagged him as bad guy, could be test, all kinds of other interesting things. The typical work hours is something I wanted to highlight real quickly. I don't have to go in and train the system. This is the beauty of unsupervised machine learning. I don't go in quarterly when people, switch roles and tell them Josh is a day worker. He's in Chicago. He works from 9 to 5. None of the rest of that. I don't have to worry about the days of the week either. I'm not going to beat that to death, but just so that you see what typical looks like. All right. So I'm going to pop in here. I'm going to change the order from ascending to descending because I want to see the attack as it unfolds over time. So I'm going to reverse the order of what's going on. First thing I do is I look at this first anomaly. It worked in an unusual hour. So I'm going to click that, pop it open. Bam. Romper Room graphics right there. I can see clearly that Josh works sometime between midnight and 1:30. Very unusual for this user. If I want to grab that and attach it to a case, I click the blue tab and it opens up a PDF for me pretty quickly. It's a PDF, I know, not terribly sexy, but for those of you like me who've ever had to do screenshots and paste them into a case, this is a godsend. It gives me all the graphics, all the text. It even would if I had highlighted tags, it would show me all my tags listed right here. That's actually pretty handy. Okay, so I grabbed that, I attached to my case. Roll down. My next anomaly looks like he moved 767 megs in an hour to this legit website. That's a lot of data. Let me take a quick look at this. Okay. The average for other users is kilobytes. This individual moved hundreds of megabytes. That's my first indicator. This is bad. Let me take a look at it. Because like I said, I'm a budding web developer. I don't have to know a ton, but I know how web transactions work, right? You get a get, you get a post, you pull data, right? It's a give and take. You open up the events. I see an agent string, which those of you that are familiar with ArcSight recognize those strings. I see the client. I see the name, the host that was visited, all the rest of this, and I see post and connect. And I just said a minute ago, I wanted to see some gets. So I'm not getting anything back from the website. All I'm doing is pushing to the system. I don't even have to look any further. And all of a sudden, I'm starting to think in the back of my head, command and control. I click on Explore Raw Events, going to open it up, and all of a sudden, bam, this pretty much right there, that visualization validates in my mind, this is a system. People don't behave this way. People see the bright and shiny, they pause, they stop, they take a look. They're not methodical like this. This is extremely uniform for this kind of a graph. So that's my secondary piece is this is command and control. That computer is sending out to another site. So bam, I've just validated that it looks like malware. He could have hit something off of a phishing email, something else, visited a website, whatever. But at this point, I'm going to say something's wrong with his system. Let me keep going through here. Take another look. So pop down and it looks like, oh, normally he pops in at 2.5 times, right, in an hour. Well, looks like he logged in 45 times. Now, I don't know about you, but I've got one of those corporate passwords. It's 15 characters, upper, lower, crazy characters, all the rest of that. Typing that thing in once a minute for an hour? I don't think so. This looks suspicious. So I'm going to go ahead and do that same thing. Look at the events, pop it open, and I see success. Okay, so no fails. What I thought was maybe somebody had accessed that computer and was just kind of doing a scan real quick. So didn't kind of really bear out my piece. Let me take another look. Hold on a second. That's not uniform. A computer would be very, very methodical, very uniform in its actions. This looks like a person. So I'm going to say at this point fairly comfortably that a person accessed the system with Josh's credentials and successfully navigated throughout my environment. I'm going to go ahead and keep looking. So I'm developing a picture of what happened. I see that they accessed a number of network shares. Let me open this thing up. Okay, here's another case where Romper Room graphics really helped me out. I don't know, Josh. How many projects does he ping in an hour? This shows me that normally he does 1 project in an hour, and sometimes he'll grab 3 because he's got to pull data back and forth. 38, way off the chart. Also, if he was covering for one of his peers, if they had high numbers like this, it's possible, right, that he covered for Sally or Bob or Tom or Sue, but they also have low numbers. This is just adding to this is a hacker got their credentials, scan up my network. I'm going to pull down a little bit further and see 19 projects in an hour. Let me open up. This looks normal. So, okay. This is a case where he's actually accessed more in the past, but because this is tied in with that other potentially shaky activity, it flagged it. That goes back to our data science models that trigger on unusual activity. Let me take a quick look. I can see the project names here, and I can see ads and prints and movement of data in and around those individual products. That's kind of weird. Let me take a look at the raw data. Once again, this is not uniform. It's not a computer virus or something moving itself to those shares. This looks like a person moving files back and forth. Maybe they found one that they can do something interesting with, right? Read, write, access something. So this looks like a person yet again. Come back in here. I'm going to go ahead and probably I would tag that one as well with an indicator, right? As I put a little eyeball on it. Hey, this is important. When I come over to take a look, I put that eyeball on it. And I would also create tags on some of these. So as I roll down, I'm going to go a little bit further because getting pretty close to 8:30, boss is going to be in. I want to continue and wrap up my investigation. So I'm going to look at this. 1.3 gigabytes moved through the proxy to an external website when most people in my environment only do about 30K. I've got a real problem all of a sudden, right? I knew I had malicious code. I knew I had somebody poking around in my data. At this point, they've moved a ton of data. That's a technical term for those of us in the South, keeping it politically correct. There's other terms I could use, but we'll just stick to a ton. So they've moved a lot of data out of my network. Like I said, I got a real problem here. The other thing that's interesting is the highest expected from any user would be that 767 that this same user did. By comparison to everybody else, this person has moved more data than anybody else out of my network. I would probably grab that as a PDF to attach it to the case just to show that this is, right, this is unusual. Roll back down, see he worked at an unusual hour, right? And we've seen what those look like. This one's after 3 p.m. or 3 a.m. We know this person works during the day. That's probably that hacker or whoever compromised the account with the beaconing activity earlier, actually in and doing something in my environment. I would probably tag that one as a PDF and attach the case as well, showing initial compromise and then activity in an odd hour. And then finally, I promised to roll down, and I am not seeing my violation. Interesting. So normally, if the DLP system or something else identified a bad activity, it would throw a V for violation. And when I pop the violation open, it would show me what rule was violated or what system showed the potential activity. And so I'm going to roll back over to my legit.com piece that was my initial indicator of compromise that looked like that was something beaconing or command and control. I don't know if anybody else has been to that website yet, but I want to go ahead and tune this. And like Jason talked about, those W's or those weights, I want to apply a weight to this. Now, the good thing for all of you that, you know, were terrified in high school math, this is so easy. Even a country boy from Georgia can do it. You can stay logged into the system. Oops. Try that again. Yep. All right. I'll play you a game. Give me just a second. Sorry about that. So I come down, I go back into Joshua. I'm going to go ahead and slide this up. You guys get to see a quick repeat. Bam, I come in. I'm going to change all the activity to ascending. I'm going to roll in and see that legit website, click it open, and I'm going to apply tuning to it. Now, the nice thing about this tuner is it's a slider, but more importantly, some of you may have noticed, and I apologize for the tiny font, is that it gives me a number of anomalies that are going to be impacted by this slider. In this case, if I take it and I shove it high, bam, I'm going to impact 26 anomalies. 3 o'clock in the morning, I'm a little coffee deprived. I'm okay with that. Not going to be terrible. If that was 8,962 or some other random number out there, I might go, whoa, whoa, whoa. I think I'm going to make a note and I'm going to let the day shift guys take a look at this and make sure, you know, this isn't a new B2B or we're buying a company or something like that and I don't know about it. I don't want to make that super risky because everybody in the world will be talking about me next week. So beautiful thing here is the slider lets you take it high. And if the morning shift folks come in and say, oh yeah, we're going to buy legit, that was somebody taking a look at their website, I can go ahead and just make it low so that it doesn't tag everybody else who pushes data back and forth to legit as a potential threat. So kind of weighting and changing the weight. The system is intelligent, and as they start to use it, the system will go ahead and make that normal for all of my users, and it will fall off of my radar and it will drop their risk scores appropriately. Notice I don't have to go back and train the system for a week. I don't have to open up a ton of consoles and make a ton of changes. As a security analyst, right, I just post a note to the rest of the team, hey, things going back and forth to legit.com, we're going to see a lot more activity. Don't freak out. Freak out's another technical term for those of you that may or may not have seen it. Down here, I promised to show you a violation. This last piece has got a V on it where the others had alert or anomaly. I'm going to go ahead and pop this open for you. So while that person, Joshua, was moving 1.3 gigs in and out of my system, the DLP system tagged him as moving credit card data. And hopefully we blocked it with our tools. If we didn't, we need to use something like the SOAR that's built into ArcSight's new Enterprise Security Manager, the ESM. And for those of you that didn't know, I just spilled beans. We are building a SOAR directly into ESM. Not an optional purchase, no subscription fees. We think that automated responses to this kind of activity are essential, and we're putting it into the product line. So you're welcome. If you haven't seen that before, bam, you heard it here first. I'm going to roll back over now to my overall risk score, and I'll feed questions if anybody has some.
Hey, Will, I saw one. It was from Tom. What volume of logs from how many different sources are typically needed to ensure an accurate UEBA outcome? And he said he figured EDR would be in there. So EDR is a rich source of data for us. We can work with one log source, guys. Most customers deploy with, say, 3 to 5 log sources, and I'll just kind of list off the top 5 most common ones. Access, right? So whether it's Active Directory, IAM, Linux PAM, endpoint, right? So CrowdStrike is a rich source of data for us. We've been a long-time partner with them, but we do support other EDR and endpoint tools as well. VPN and proxy are kind of really common ones for us as well. And then I guess the last one to round out would be our repository. So where do you have code sitting that you care about? That's often a source code library. But it's also could be a SharePoint library or some other thing. So again, the caution I'd have after doing this for 5+ years in the UEBA space is don't try to boil the ocean, as with everything crawl, walk, run, and then try to ultra marathon. Figure out the use cases that you're trying to cover. That'll help you point to the log sources that are going to feed those use cases. And we've actually mapped all 450+ models in the Interset tool to the MITRE ATT&CK framework, and we share that with our customers in a kind of a tabletop exercise, or virtual tabletop these days, where we want you to understand how the models work, where we'll have coverage, and frankly where we aren't the right tool, so that you have the best outcome as possible.
That sounds good. Thank you. Hey, one other question that sometimes comes up that you may or may not have fielded in the chat window is what happened with that legit.com website that Josh hit, right? If I go back into Josh real quick and tune this up and kind of zoom in, notice I didn't move the slider, right? So when I found that website down here, I didn't actually apply that tuning. You saw that I went in there, but I didn't actually apply it. So what happens with the system is, right, is that still there? What's going on? One of the really nice things is as I go back into my overall risks page and take a look, I'm going to hit websites. The system automatically identified that as a potential exfiltration threat. And because of the risk score associated with the user who was using it, it gave them a corresponding risk score. So it jumped it to the top of my list. And so any other users, regardless of whether or not I move that slider, that access this website, they're also going to have a correspondingly higher threat score because this site simply is under threat.
True. Got another question that came in here, Will. Jim wanted to know who watches the watchers, and there are a couple of ways we can address that. One, we can tokenize all of this data. So instead of seeing legit website, it could be website 123, and that's tokenized. And there's a process around who gets to see the actual user. That's more applicable, say, in a GDPR or Workers Council kind of thing across the pond where you're watching users. But there's also a complete log trail in here. So when Will went in and showed you how to tune down an event because he's lazy and doesn't want the alerts, well, there's a record of that. And so it'll definitely leave a log trail or audit trail rather of who is turning the knobs, if you will. And often, watching the watchers, we're seeing a lot of our customers, kind of play red team, activity with us, seeing if they can get caught. And it's great to hear that them say the Interset caught everything the red team threw at them.
Absolutely.
And as far as there's another question about where do the data reside. So there are multiple deployment options for this. There's SaaS-based offerings, whether it's the CrowdStrike only SaaS offering. There's a SaaS-based offering for the core ArcSight Intelligence Intercept beyond just CrowdStrike as a SaaS. Of course, the data is going to live in AWS or fill in the blank cloud provider there. But there are also hybrid solutions for deployment as well as on-prem. Several of our can't confirm or deny kind of customers deploy on-prem, obviously, in a secure environment.
So that's a great question. And tying into that obfuscation piece, some of you may be aware of voltage and the format preserving encryption that exists there. That's great because it lets you take a name and keep it a name. It doesn't throw a hash. But if for some reason you split your data in Europe or some other region where you'll have to, do extra diligence with your stuff, if you throw me a hash, like you saw in our slide deck earlier, I can actually compute against the hash. So the name doesn't have to be a name, it'd be nice, but I can actually run the mathematical models against a hashed value as long as you don't have a salt or a randomizer in it so that the hash is always the same. Josh Newman becomes ABC123. As long as it stays consistent, I'll run analytics on ABC123. And then somebody who's got access to the backside data can go through and do a mapping for ABC123 back to Josh.
Yeah, absolutely. And it's multi-tenant as well. So we could certainly, even create our own tenant for a separate business case. Another question just came in, question on the risk calculator, who assigns the weight value to the asset. You don't have to go in and classify your assets. You can, as we showed with the weighting, you can increase the value of an asset. So it's something that's done off the shelf, but if you want to increase the weight for whether it's an asset or a user or a method, you can certainly crank the noise up on that or down.
And another answer to that question is if you've got data scientists in your environment or insider threat specific analysts who want to interact with the system before sending it over to the SOC so that they can look at it, we'll certainly work with you so that your data scientists work with our data scientists. And you guys, if you've got a very specific classification system, like the Air Force, or federal agencies or financials, we can definitely support that. And if you tag your repositories appropriately, we apply the correct weighting to those repositories. Maybe you're a certain beverage manufacturer here in Atlanta, and you've got a secret formula, and you want to pop up the score for anybody who grabs that formula and starts moving it around. We can definitely help you with that.
Yeah, the tags really make it nice to slice and dice the data for hunting, but also for API calls and reporting. So that's another nice feature about it.
I had talked about the weighting real quick. I'll give you an example. I think this one will work. If I hit the tag for that particular system, it comes back. Funny how that works, huh? This is the one with tagged for the credit card data. And so if I did just a tag for that EX210, I could then take a look without Joshua to see if anybody else triggered against the system. And so I can use those tags pretty quickly back and forth dynamically.
Well, I'm not seeing any other questions in here. For a very complex platform, it demos very easily. And that's what we're all about, is really trying to simplify security operators' lives, right? You provide less alerts with more context and meaning around them. Before we close down 5 minutes early and give you guys back a few minutes of your day, any other questions, please put them in the chat window, going once, going twice. Otherwise, please just reach out to your local Micro Focus person or Jason Black at microfocus.com or Will Willoughby at microfocus.com, and we'll be happy to help you. We appreciate your time today.
One last parting note for those of you that have got CISSP or other security credentials. This counts as an hour. Go out there and grab your CPEs. Congratulations on getting your certification, and glad we can help you keep it.